Welcome back to Frustrated User Guide. This is the fourth video in the Measurement Confidence playlist. That playlist is designed to teach young electronics students not to trust their test instruments and hopefully become as successful in their repair efforts as I have been. Now today, we're going to be testing standard automotive blade fuses. If you've heard it once, you've heard it 100 times. If it beeps, it's good.
If we hear a beep, we're good to go. First fuse, good, 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 good. All right, fuses are good.
That was Joe Weber from the Great 2 Vintage channel. Joe, I've learned a great deal from you, but you're not testing fuses correctly. Let me show you. So, first thing we're going to do is check out our test setup. I have my reliable Fluke 12 multimeter. Come across, it's on the beep test. We're going to put it on ohms. Alright, auto ranging on the mega ohm scale right now. I'm going to change to my clip leads. Now the first question, what is the resistance of a fuse? You just grab any of these. Sometimes they're a little corroded. That one's got some corrosion on the lead, so we'll scratch it when we attach our test leads. Try to get good contact. And according to my Fluke 12, this fuse is reading 0.2 of an ohm. And we'll try the beep test. Yep, beeps. If it beeps, it's good, right? No. All that means is that the resistance of the fuse, which is supposed to be 0.2 of an ohm, maybe even less, because what's the resistance of our test leads? It's adding maybe the resistance of the test leads is only 1/10 of an ohm. So that fuse is no more than 1/10 of an ohm, according to this meter. And if it passes the beep test, that doesn't mean that it's reading 1/10 of an ohm. It only means that its resistance is less than the beep threshold of this meter. And that's the question. What's the beep threshold of the multimeter that you're using? Does anybody know right now? Do you know what the beep threshold is? So we're going to test that. Because if the resistance of this fuse has gone high, very often this is the cause of an intermittent problem that you cannot solve. Everything tests good, but the circuit doesn't work. You can't find the problem, you give up on it. Now, I don't care how much experience you have. There are always devices that you can't fix. No doctor can cure every patient. I look back on my career at the things I couldn't fix, and with experience that comes with age, you begin to think, gee, I wonder if that's what was wrong with that. So, what's the beep threshold of this meter, which is the best meter that I own? Let's find out. So what we have here is a decade box. This is a very cheap Chinese decade box that I got from Temu. It was around $10 or so. It's not particularly accurate, but we've got 4 range switches. As you increase this, this goes up by 1 ohm. As you increase this one, it goes up by 10 ohms, and they add, so that would be 10 ohms. Do this, now I have 11 ohms, roughly. Precision is within a few ohms on this, but okay, good enough for what we're going to use it for today. So I'm going to attach my alligator clips to this. We're reading 1.7 ohms, pretty good. Now I'm going to put on beep test. Let's increase this by 10 ohms. Beep test is indicating 13 ohms. It's still beeping. Let's go to 20 ohms. Beep test is indicating 21 ohms. That would be the 20 ohms from this range switch, plus maybe an ohm or two from the test setup, test leads. 30 ohms, still beeping. 40 ohms, still beeping. Now I know it doesn't say 40 ohms here, but we've got the resistance of the meter, pretty accurate. You're going to see other meters can't even do that. And the tolerance of this cheap decade box. 40 ohms, still beeping. 50 ohms, still beeping. 60 ohms, still beeping. 70 ohms, still beeping. 80 ohms, still beeping. 90 ohms, still beeping. All right, let's add these. 91, 92, 93, 94, 95, 96, 97. We're at 97 ohms, reading 83 on here, still beeping. 98, 99. All right, let's do this. Times 100. This should be 100 ohms. Okay, so roughly on this meter, the beep tolerance is about 100 ohms. Let's go to the ohms scale and see what it says. 101.4 ohms. So roughly 100 ohms. Okay, what does that mean? So you have an intermittent problem in your automobile and you just tested these fuses and it beeped. All that means is that the fuse, the resistance of this fuse, which should be 1/10 of an ohm, is less than 100 ohms. Let that sink in. The beep just means it's below the beep threshold of the meter. And your car is powered by a 12-volt battery. This is powered by a 9-volt battery. 9-volt battery can only deliver about a half an amp at 9 volts. Your car battery can deliver, well, if you got a 15 amp fuse that you're testing, 15 amps at 12 volts. This is a half an amp at 9 volts maximum. So you have a fuse that has overheated, that has gone high resistance. Usually when it overheats, this might be brown in here. Hard to see though when it's in the car like that. And under certain circumstances, you're stepping on the brakes and it's hot or it's cold, you'll have an intermittent condition that drives auto mechanics absolutely crazy, and they never suspect this because it passed the beep test. So okay, we now know. This Fluke 12, the best meter that I own, hey, I had it for decades, it's absolutely fantastic. If you can find a used one, this is what you want. The beep threshold's about 100 ohms. Let's try some other meters. But first, I'm going to enter that. This is a scientific method, so I'm going to enter that into a spreadsheet over here. Fluke 12 beep threshold, roughly 100 ohms. I've got this ready to go. Alt 234 for the ohm symbol. There we go. Okay, save it. Alright, so next we're going to test this clamp meter. Had this a very long time. Until today, I never questioned the accuracy of this meter. It's a 10 mAh, and the model number is 72-7224. Pretty nice meter. I've used it a lot, mostly for measuring AC. So we've got the same test leads connected that we used on the Fluke 12. We're clamped on our binding posts here. Verify that the switches are all at 0. This one is not. Let's put that at 0. I'm going to start out at 0. Put this on our ohms scale, and we get the 0.2 of an ohm, or 2 ohms, I guess. That would be 1 to 2 ohms. Okay, let's put it on beep test. She's beeping. Now we'll do the same exact test to determine what the beep threshold of this meter is. 10 ohms. The meter is currently seeing it as 15 ohms. Not very accurate, but still beeping. 20 ohms. Meter sees it as 24, still beeping. 30 ohms. 34, still beeping. 40 ohms. 45 ohms, and 45 plus, still beeping. 50 ohms. Still beeping. Reads it as 56 ohms. 60 ohms. So you can see there's like a 6 ohm high on every one of these. Still beeping. Goes off at 70 ohms. So there you go. Now this meter gave such bizarre results when I did this a few minutes ago. I changed out this battery for a brand new battery because I began to suspect that what you got might be a function of how strong your 9-volt battery was, or your penlight batteries. This is actually making a little beep noise. Do you hear it? Alright, let's put it on resistance and see what we get. Where are we? According to this, we're at 45 ohms. According to the decade box, right here, we're at 70 ohms. So what we're learning today, the ohms scale is not very accurate, especially when you're on beep mode. Let's go to ohms right here. What does that say? It says 76.4, so it is high. But that's your beep threshold. It's somewhere around 70 ohms. Okay? This meter, beep threshold was 100 ohms. This meter, beep threshold is 70 ohms. Put that in our spreadsheet. Okay, so next we've got a cheap Harbor Freight, I should say cheap, inexpensive, Centec model CM300, otherwise known as the Blue Harbor Freight meter. So I'm going to use the same test leads. Keep everything the same. Alright, I want to make sure that all of these are set to 0. This one is not. Set it back to 0. Okay, turn this on. We'll put it on. Here's our beep test right here. Well, this meter's reading a little high. All the other meters are at about 2 ohms. This one's reading 4.2 ohms. 4.1. All right, let's go to 10 ohms. Reads 14.6. That's our differential. Going to be that 4 point something ohms differential. It's reading too high. All right, 20 ohms. Still beeping. 30 ohms. It stops beeping at 30 ohms. Try that again. Beeping at 20. Stops beeping at 30. So the beep threshold on this meter is 30 ohms. Now let's put it on ohms and see what it actually says. I'll put it on the lowest ohm scale here. Shows 34.7 ohms because we're always reading about more than 4 ohms too high. But okay, beep threshold on this one's a lot lower than this Fluke 12, which has a beep threshold of 100 ohms. So isn't that interesting? 70 ohms, is that what it was? 70 ohms on the 10 mah clamp meter, 30 ohms on this one, 100 ohms on this one. Oh yeah, precision test instruments, that's what we got here. All right, 30 ohms, going to put that in the spreadsheet. So next we have a B-side, model ZT-QB9. This is a very unique AC/DC clamp meter. We used it in the backup power project because it can measure the inrush current of an electric motor. So extremely useful and not very expensive. Plus it's kind of automatic here. So first we'll check our decade box. 0, 0, 0, 0, all at 0. Same test leads. Let's turn it on and see what we get. It should go right to beep test. Okay, so it's seeing the resistance of the test leads as 4.2 ohms. Quite a bit higher than what our better meters said. But okay, that's going to be our differential. So when I go to 10 ohms, it'll probably say 14. Says 16, still beeping. 20 ohms, still beeping. 30 ohms, still beeping. 40 ohms, still beeping. 50 ohms. So plus or minus roughly 50 ohms is the beep threshold of this meter. So if you're testing a fuse with this meter and it beeps, it just means that fuse is less than 50 ohms at 9 volts. All right, let that sink in. All right, 50 ohms, going to put that in our spreadsheet. All right, next we've got my reliable Fluke 10. This is the meter I usually grab when I need to measure voltage in a car. Kind of beat up here. All right, same test leads. See what this does. Double check 0, 0, 0. Let's put this one back at 0. All right, going to turn this on. We'll see what the Fluke thinks of this test setup. All right, it's seeing 3 ohms. Actually reading 4.2 ohms here. Not as accurate as my Fluke 12. So on beep test it sees 3 ohms. That's 10 ohms, reads 14. 20 ohms, 30 ohms, still beeping, 40 ohms, still beeping, 50 ohms, still beeping, 60 ohms, still beeping, 70 ohms, still beeping, 80 ohms, still beeping, 90 ohms, still beeping. All right, let's go on this will be 100 ohms. Well, let's try this. That's 90 ohms, 91, 92, 93, 94, 95, 96, 97, 98, 99. So that would be 99 ohms. All right, let's go to 100. Right about 100 ohms it cuts out. So just like the Fluke 12, the beep threshold on the Fluke 10 is roughly 100 ohms. Okay, let's enter that into the spreadsheet. So just remember, if you're using a meter like this, which I've used hundreds of times, to beep test an automotive fuse, all the beep means is that the fuse is less than 100 ohms. Nowhere's near where it's supposed to be. Fluke 10. Next we have a Chinese Fluke 17B. Believe me, this is nothing like my legacy Flukes. I've not had very good luck with this meter. But let's see how it does. Okay, same test leads. Starting out at all zeros. Let's see what this meter thinks of the test setup. Okay, it's seeing 1.2 ohms. That's pretty good, because some of our cheaper meters we're seeing a lot higher. So this is more accurate than a few that we've tested so far. Put it on beep test. Seeing 1 ohm. Okay, 10 ohms. 20 ohms. 30 ohms. 40 ohms. 50 ohms. 60 ohms. Heard a little skip there. 70 ohms. 80 ohms. Another skip. Starting to balk at 80 ohms. 90 ohms. How often have you heard a mechanic in a YouTube video testing a fuse where it's beeping like this? Intermittent pulsing. Oh, if it beeps, it's good. No, no. 91. 92. 93. 94. 95. 96. Sounds like Morse code. 97. 98. 99. We're still beeping at 99 ohms on this very expensive Fluke. Alright, set it back to zeros. Gonna try the times 100 scale. 100. Still beeping at 100 ohms. 110. Oh, if it beeps, it's good. 120. There you go. Beep threshold on this meter is about 120 ohms. Oh, got a little beep there. Now this is a plus or minus, but roughly 120 is the beep threshold on this meter. That's not good. And in fact, 100 ohms on this meter is not good either. Okay, Fluke 12, actually 17B plus. Let's enter that into the spreadsheet. Set these back to 0. Well, that reading was so high, I went back and checked it a second time to make sure that I hadn't made a mistake. So let's look at this. We're at 103 here, 110, 120. There's no doubt about it. It's 120. 100 ohms here, 20 ohms here. And that's what it's showing. That's where it stops beeping. Pretty high. Next we're going to try this amp probe. This is a model AC/DC 52 NAV, $500. I also bought this for use on the backup power project. Big mistake. But let's see how it does here. Okay, same test leads. Make sure that all of our, oh, this one's still on 100. Put all our settings back to 0. Okay. Well, that's good. It's showing 1.4 ohms, which is what, more or less what this showed. All right, let's increase it. 10 ohms. 20 ohms. 30 ohms. 40 ohms. Look how far off that is. 50 ohms. And we're off at 60 ohms. Go back to 50. Nope, 60's working now. No, we're still beeping at 60. Let's use this, 61. Off at 61, so I'm going to say that 60 ohms is the threshold. You go back to 60, it's beeping. 61, it's off. So there we go, 60 ohm threshold on the amp probe. Put that in the spreadsheet. Next we've got my Fluke 37. Okay, we've got the probes connected with a very tight fit. Chinese leads, American meter. We've got our decade box set back to 0. All the rotary switches. Let's activate beep test. One ohm, 0 ohms. Look at that. A lot of our cheaper meters were reading 4 or 5 ohms here. All right, let's go to 10 ohms. Telling us it's 7, 20 ohms, 30 ohms, 40 ohms, 50 ohms, 60 ohms, 70 ohms. Wow, only seeing 44. 80 ohms. 90 ohms. 91. 92. 93. 94. 95. 96. 97. 98. 99 ohms, but beep test is only seeing 61. Let's switch to the ohm scale. Ohm scale sees the 99 ohms. Back to the beep test. Still beeping. Alright, going to set these back to 0. We're going to use the 100 ohm scale. That's 100 ohms. See it right here on the 1. 110. 120. 130. 140. 150. We're still beeping at 150 ohms. Let's just check what the resistance of that circuit is. It's seeing the 150. So the 1.2 ohms would be the resistance of the test leads and the box itself. And we're still beeping at 150 ohms. Oh, if it beeps, it's good. Yep. 150 ohm fuse causing all kinds of automotive intermittence. If it beeps, it's good. 160. And there would be your beep threshold. Somewhere between 150 and 160 ohms. So, all right, let's go back to 150. See if we can find exactly where it is. 151, 2, 53, 154, 155, 156, 57, 58, 59, 159, 158. There you go. Shuts off at 159. Oh, we're still getting it. So it's about 160 ohms. So if you were using a meter like this to test a sensitive circuit, and you were relying on the beep test, all that tells you is that the fuse is less than 160 ohms. Doesn't tell you that the fuse is good. Well, let me enter that into the spreadsheet. Now, scientific method requires that a reproducible experiment be conducted and documented. You've just seen that. And it requires that the results be published. Here are my results. Now, the challenge is for you to try to reproduce these results with your own meters. Now, in my case, the average cost of my meters is $163. And the average beep threshold of those meters is 86.25 ohms. That is way too high in my opinion. Now, what should the beep threshold be? Well, according to Fluke, the level of resistance needed to trigger the beeper varies by meter, but most will indicate continuity with a measurement between 0 and 50 ohms. Well, I tested 4 Fluke meters today, averaging in price from $150 to $229. That Fluke 37 in today's money would be more like $550. And none of them averaged between 0 and 50 ohms. Now, the next question becomes, how do you define continuity? Well, for me, continuity is all zeros, like we saw on that Fluke 12 across the fuse. All zeros. No resistance whatsoever to the flow of current in that wire. And how does Google define continuity? Well, if we just look here how to test for continuity, set the meter, touch the probes, listen for the tone. If there's an uninterrupted path with very low resistance, the meter will emit an audible beep. Yeah? If the path is broken or the resistance is too high, it will not beep. But that's at best, that's misleading. If there's any resistance to the flow of current in that wire, that's resistance. That's not continuity. Not in my opinion. Now I know there are going to be deniers. They are going to deny my opinion. They're going to deny my results. They're going to say it doesn't make any difference if a fuse has a resistance value of 100 ohms. Well, that's wrong. Let's go prove it right now with a real world example. So recently I had a problem with one of my 20-year-old Volkswagens, intermittent brake lights. So the car comes home and there's no brake lights. So the first thing I do is check the fuse. Now the fuse in the brake light circuit is a 10 amp fuse, and it's in a fuse box with a dozen other fuses or 20 other fuses. And you're looking at it like this. So I've got it in a little vise here to hold it. And of course you put your meter on beep test, and the first thing you do, that's what I did, go over to it, touch the probes like that. If it beeps, it's good, right? No, it wasn't good. But I didn't catch it when I did that because I wasn't paying attention to this. Watch. We got continuity now. All zeros across the meter. But who looks at the meter? You're just listening for the beep. But okay, so we know our fuses got continuity. Now I've got a single 12-volt bulb here. That car has 5 brake lights. We've just got one. I'm going to turn on my 12-volt power supply. Got a little analog amp meter here. We'll see what it does. It's quite bright. And according to this, we're drawing about 3/4 of an amp through that one bulb. Now the circuit, it's a 10 amp fuse. So VW is expecting 10 amps through that brake light circuit, or maybe at least 5, and they overprotected it. I really don't know. But we got 5 at 3/4 of an amp. That would be what? Almost 4 amps. 3.75 amps if they're all lit. And then again, this is just a little power supply. Your car battery can produce a lot more current than this thing. So that's the bulb. Now I'm going to run it also through this Fluke 17B Plus. And we'll check the current draw here as well. So now we reproduce the experiment with the 10 amp fuse in place. Let's see what happens. And the lamp lights nice and bright with the 10 amp fuse in place because we have continuity. There's no resistance here. Now we learned that these meters I have my chart here. The meter I had used to check the fuse was a Fluke 10, and it passes up to 100 ohms of resistance. But the actual fuse that was causing all my trouble had gone about 70 some ohms. So what I did was I made up a little, put two resistors in series. Let's see what that measures. So in ohms. So we have about 77 ohms here. Let's see what happens to the circuit when we replace the 10 amp fuse. We replace continuity with resistance. What do you think is going to happen? Makes no difference, right? Fuse beeped, so it's got to be good. Can't possibly be causing a problem. Alright, so we've replaced continuity with resistance. Let's see what happens. Well, we've dropped our current through the one bulb from 3/4 of an amp to less than 2/10 of an amp. That's 180 mils there. And the bulb, I'm going to turn off the lights. It's just barely lit. I don't know if the camera can show it. We can see something now. Now imagine, there's 5 of these in the car. No wonder I have no brake lights. But it was worse than this, because the condition was intermittent. How can that be? Because the fuse had gone high, but it became a variable resistor. The resistance of the fuse was changing depending upon temperature and driving conditions. Now heat will increase resistance. How can that be? Because if you're stuck in traffic and your foot is on the brake for 5 minutes, 10 minutes, 15 minutes, and you're just inching along with your foot on the brake, then this heats up and it goes higher and even higher resistance without burning out. And the fuse was my problem. But that wasn't... I only detected that when after a great deal of troubleshooting, deoxing connectors, changing bulbs, ripping out upholstery, following the wiring harness back, removing the fuse box, that's when I saw some discoloration on this body. But it wasn't just this body. There were other fuses in that fuse box that had gone high resistance. How can that be? Well, it's a Volkswagen. Every Volkswagen I've ever had. Mechanically superior, mechanically advanced, electrically inferior, electrically retarded. I don't know what they used for OEM fuses, but that was the problem. When this happened to me, I was so angry with myself. I should have known better. This is the 3rd time I've run into high resistance fuses in close to 60 years of electronic sales and service. I know better, but you're so used to just, we got no brake lights, it must be a bad fuse. Oh, it beeped. If it beeps, it's good. No, it's not good. It's hard to do, but you have to observe the meter. You've got to observe the digital display on the meter when you're beep testing. And if you're not seeing close to zeros here, if you're seeing high resistance here, even though it's beeping, it's not good. So I wasted a great deal of time and even more time making this video. So I hope this helps someone. Hope this helps you to solve those intermittents that are driving you crazy. If so, please leave a comment. I'd also be very curious to know what the beep threshold is on your meters. So if you care to say the make and model of your meter and what the beep threshold was, much appreciated. So hope this helps someone. Thanks for watching.